Hello. I want to show the proof of these two formulas that says the first one says is the time taken to reach greatest height is given as u sine alpha over g. Let me just say one here. And the second one is equation of the trajectory. Actually, there's no need for me to write it down because it's also written in the example. The equation of the trajectory, which is y, equation of the trajectory is also given as this one. So normally these formulas you are allowed to use them to answer questions because they'll be given in whether it's A level or it's university mathematics for you. But there are questions that would say prove that this formula is what it is. So here we've got a question that says prove, and it is given a very long question that says a particle is projected from a point with speed u at an angle of elevation alpha. So I've just drawn the particle is projected here at an angle of elevation alpha, which is this alpha here. This is our y and this is our x. So when the particle is moved a horizontal distance x, which is this part up to here, and I can say this is t, takes us t time. Its height above the point of projection is y. Show that y can be given as this formula here. So a few of the things that we can recall here is this is a projectile at an angle. So as it reaches this point, it's stationary. The final velocity is 0. And as a result, this is the height we are talking about. So if you can remember, to find the displacement, which is x here, or we can say to find the displacement here, which is x, I have to resolve horizontally. If I resolve horizontally, we know that the velocity from this point here up until this point here after t is ux, because acceleration is 0. So we're actually going to have ux is equal to u cos alpha, which means that x is u cos alpha times t, which we can just conclude that it is t u cos alpha. That is the displacement x. We can also calculate the vertical, which is the vertical displacement, by using s is equal to ut plus half gt squared. Remember, we've got the initial velocity, which is u sine alpha. So this is u sine alpha times t minus, since g is negative, going down is negative, minus half gt squared. That is how this will look like. We can call this equation number 2, while this is equation number 1. So if we make t the subject of the formula from equation number 1, so we can say from 1, t is actually equal to x over u cos alpha. So we can see what we want to do. We want to show that this is in terms of x and t. So we're going to say this is equation number 3. So we substitute, next point is to substitute 3 into equation number 2 so that we can eliminate t in the equation 2. So we are going to have y, well, s, it was s of y here, so let me just call it y vertically, is equal to u sine alpha times x u cos alpha minus half g squared in brackets. This is t, so it's going to be x, this is g squared, over u cos alpha squared. So this is the same as saying xu sine alpha over cos alpha minus half g squared x squared over u squared cos squared alpha. What's very important here is to acknowledge a bit of your trigonometry. So if you go back to your trigonometry, you know that tan alpha is equal to sine alpha over cos alpha, and you also know that sec alpha is equal to 1 over cos alpha. So using these two, this also implies that 1 over cos squared alpha is equal to sec squared alpha. So we can now substitute this and say, therefore, y is equal to xu tan alpha minus 1 over 2 g squared x squared over sec squared alpha. So once we get x squared over sec squared alpha, there's no need for us to say over sec squared here because I've already indicated that 1 over cos is sec squared, so this should actually read sec squared alpha. So we are almost there now. How do we change sec squared alpha? You have to go back again to your trigonometric identities. Remember, if you say sine squared alpha plus cos squared alpha is equal to 1, and if you convert this by dividing both sides by cos, you're going to get sine squared alpha over cos squared alpha plus 1 is equal to 1 over cos is okay, let me just write it down here. Actually, let me do this. Cos squared alpha over cos squared alpha, 1 over cos squared alpha. So this gives us tan squared alpha plus 1 is equal to sec squared alpha. So this is the identity we need to use. So we substitute that. So this, therefore, this is equal to y is equal to xu tan alpha minus 1 over g squared x squared in bracket where there is sec squared, we write 1 plus tan squared alpha as required, shown. So that is a proof for a very important equation of projectiles to use in your examinations.